Hello everyone, welcome you back for the session of the module 2 in fluid power systems. In the module 2, what we are discussing is nothing but the two parts. The first part is nothing but the pumps, the second part is nothing but the actuators. Even in the pumps also, the different types of pumps, like either it may be the vane pumps, piston pumps. Even in these pumps also, what we are discussing is the fixed displacement pumps and as well as the variable displacement pumps, depending upon the application. The next part what we are discussing in the case of the pumps is the accumulators, the types, selections, design procedures, application of the accumulators, the types of the intensifiers, pressure switches, temperature switches, and as well as the level sensors. In the second part of this module 2 is nothing but the actuators. In this, the classification of the cylinder and as well as the hydraulic motors. In the hydraulic cylinders, what we are discussing is nothing but a single acting, double acting cylinders, mountings, arrangements, cushionings, and as well as the problems with respect to the cylinders. The second part is with respect to the construction and as well as the working of the actuators. That too, especially rotary type of actuators like the gear, vane, piston, and piston motors. The hydraulic motors, theoretical torque, power, flow rate, hydraulic motor performances, and numerical problems and symbolic representation of the hydraulic actuators. This put together is nothing but the module 2. The first what we are discussing is with respect to the introduction. In this introduction, what we are discussing is the pump and as well as the different types of pumps, what we are using it for the application of the fluid power systems. As you know that the pump is used to convert the mechanical energy into an electrical energy. The pump is nothing but something like it's a heart of any hydraulic system, because it generates the force unnecessary to move the load or to transmit the load from one end to the another end, or it is used to perform the work. The mechanical energy is delivered to the pump using the prime movers such as the electric motors. The partial vacuum is created at the inlet due to the mechanical rotation of the pump shaft. This vacuum permits the atmospheric pressure to forces the fluid through the inlet line and into the pump. The pump is then pushes the fluid mechanically into the fluid power system to actuate the devices and to do the work. Now, in this slides, what we are discussing is with respect to the classification of the pumps. The classification of the pumps are of three different ways. The first classification is based on the displacement. Even in this also, there are two different types of displacements are there, the positive displacement and as well as the non-positive displacement. The classification is based on the deliveries. The first one is nothing but the variable delivery pumps and as well as the fixed delivery pumps or the constant delivery pumps. The third classification is based on the motion, either it may be a rotary pumps or it may be the reciprocatory pumps. The first discussion is with respect to the based on the displacement. Even in that also, the first what we are discussing is the non-positive displacement pumps. Non-positive displacement pumps are the primarily velocity type unit that have a great deal of the clearance between the rotating and as well as the stationary part. The non-displacement or non-positive displacement pumps are categorized by the high slip that increases the back pressure so that the output or the outlet may be completely closed without damaging the pump or the system. The non-positive pumps do not develop a high pressure but moves a large volume of the fluids at low pressures. Because of the large clearance space, these pumps are not self-priming. In other words, the priming action has too much clearance space to seal against the atmospheric pressure. The displacement between the inlet and the outlet is not a positive. Therefore, the volume of the fluid delivered by the pump depends upon the speed at which the pump operates and the resistance at the discharge side. Now, as the resistance is built up at the discharge side, the fluid slips back into the clearance space, and other words, the fluid path are the least resistance. The next part what we are discussing is nothing but the positive displacement pump. The positive displacement pumps are the pumps in which the resistance get a certain value, know that the fluid gets delivered to the system and the volumetric efficiency of the pump drops to a zero for a given speed. These type of universally used for the fluid power systems, and name as the name implies that the positive displacement pump have a fixed amount of the fluid to deliver for the application purpose, especially in the hydraulic systems with a particular rotation or the revolution of the pump shaft, so that the pump is capable of overcoming the pressure resulting for the mechanical loads and the systems, and as well as the resistance for the flow to the friction. The advantages and as well as the disadvantages with respect to the non-positive displacement pump. The first what we are discussing is with respect to the advantages. In that, the non-positive displacement pumps have the fewer moving parts. The initial cost and as well as the maintenance cost is very low. They gives a smooth and as well as the continuous flow. They are suitable for handling almost all types of fluid, including the slurries and as well as the sludges. See, as we know that the clearance between the two movable part and as well as a fixed part is more. For that reason only, even the slurries and as well as the sludge particles can also be used very easily. And the output of the non-positive displacement pump is a variable one. But there is no constant pressure, or the constant pressure built up is not possible in the case of the non-positive displacement pump. Their operations is simple and as well as reliable. The disadvantages of the non-positive displacement pumps are it is not self-priming it, and hence they must be primed instantly, or they are positioned below the fluid level. The discharge is a function of the output resistance. The low volumetric efficiency. These are the major disadvantages with respect to the non-positive displacement pump. The advantages and as well as the disadvantages with respect to the positive displacement pumps are they can operate at very high pressures, somewhere around 800 bars, and it can be lift oils from a very deep wells. They can achieve a high volumetric efficiency up to somewhere around 98%. They are having a highly efficient and almost a constant throughout the designed pressure, or the pressure what we can say is maintained constantly throughout the system or throughout the working environment. They are a compact unit having a high power to weight ratio. They can obtain a smooth and as well as the precisely controlled motion. By the proper application and as well as the control, they produces only a amount of the flow required to move or the load for the desired velocity. They have a great flexibility of performance and they can made to operate. The positive displacement pumps are further classified into the types of the motion of the pumps and as well as the element. Based on the type of the motion of the pump elements, the positive displacement pumps are classified into either it may be the rotary type pumps, or it may be the reciprocatory pumps. In the case of the reciprocatory pumps, normally what we are using is nothing but the piston and the cylinders. But in the case of the rotary pumps either it may be a gear pumps or it may be a vane pumps, so on. The constant delivery pumps. See, constant delivery pumps are always delivers a same quantity of the fluid in a given time at operating speeds and temperatures. These pumps are generally used for relatively a simple machines such as the saw or the drilling presses, or where a group of machines is to operate with a no specific relationship among the relative speeds. The power for the reciprocating actuators is most often provides a constant pump. Variable delivery pumps. The output variable volume pump may be varied either manually or automatically with a no change in the input speed to the pump. The variable pumps are frequently used for rewinds, or it may be the constant tension devices, or where a group of separate drives has to integrate the speed relationship, such as the conveyor systems, or it may be a continuous processing equipment. That is especially in the case of what we can say the automation systems, or it may be in the line of the automation. These type of pumps it can be used. It is a one in which the amount of the fluid ejected per revolution or the displacement cannot be varied. The classification is based on the motion. This classification is concerned with the motion that may be either it may be reciprocatory or it may be the rotary. It was the greater importance when the reciprocatory pumps consist only a single, or it may be a relatively a large cylinder, and a discharge had a large undesirable pulsation. In the present day, reciprocating pumps differs very little from a rotary pumps in either the external appearance or the flow characteristics.